Hello students, welcome to this next lecture of the chapter 2, that is lathe machine. In this lecture we will discuss about then thread cutting operation. So let us start with, for that have a look at the figure as shown over here. So first of all you can see that the entire basic structure, how all the parts are connected for thread cutting operation. So for that, as you can see, this is the headstock, this one is the live center, and this is the dead center, and between these two centers one workpiece on which threads to be cut is adjusted. So the workpiece is fixed between the tailstock and the headstock. Now this workpiece is given rotation, and at another point this tool is attached or connected towards the workpiece for cutting operation. This tool is fixed on the tool post, and this tool post is fixed on the compound rest. So this is the compound rest, and this compound rest is fixed on the carriage, and this carriage can be connected to this lead screw using a certain mechanism, and this lead screw is connected to the assembly of the gears. So now these are the connections of the different parts available in the lathe machine. Now how movement is given for particular thread cutting operation? So for that, simply look over here. Now as the headstock spindle is rotating, as the spindle has given rotation, what happens? Workpiece starts rotating. Now as the workpiece rotates, at its end portion another gear is available, and one mechanism that we have discussed in our previous lecture, that is the tumbler gear mechanism. Tumbler gear mechanism is available at the end of the headstock, and with the help of this tumbler gear mechanism the speed is transmitted from this headstock spindle to the lead screw which is connected at the bottom portion. So the speed is transmitted to the lead screw. So now with the rotation of the headstock spindle, this lead screw will also starts rotating, and on this lead screw a certain amount of pitch is available, and with which this lead screw is rotating. Now with the help of the half nut mechanism, this lead screw is connected to the carriage. So this lead screw can be connected to the carriage using half nut mechanism. So this half nut mechanism provides connections between lead screw and the carriage, and with the amount of pitch available on the lead screw, with the rotation of the lead screw, this carriage automatically starts moving in the longitudinal direction. So that is how the automatic movement of the carriage is obtained using these particular mechanisms. Now as this carriage automatically moves, this tool also automatically moves, and this tool is touched to the workpiece, and it helps us to generate the thread on the workpiece. Now how much pitch that can be generated on the workpiece and how pitch can be adjusted, for that a simple gear ratio is used, as the tumbler gear mechanism consists of the many number of gears. So these gears needs to be adjusted such that we can generate the required pitch on the workpiece. So for that one can use a simple gear ratio equation. Now let us write that. So the gear ratio is nothing but the speed of driver divided by the speed of driven. So in our case, which part is the driver and which part is the driven? So let us again have a look at the figure that we have discussed. So you can see from here on which component we need to generate the thread. So we need to generate the thread on the workpiece, and to generate the thread on the workpiece, which part provide the motion? So this lead screw provide the motion for rotation or for the movement or cutting on the workpiece. So here lead screw rotation helps us to cut the thread on the workpiece. So we can write that this lead screw is the driver, and with the driver movement the threads are generated on the workpiece. That means this workpiece is the driven. So we can write in our equation speed of the lead screw divided by the speed of the workpiece. So this is the basic equation that is generated from the gear ratio. Now we also know that pitch of the gear can be written as pi d divided by t, which you have studied during your design subjects. So here, and we also know that velocity, that is equal to pi dn divided by 1000. So keeping all other parameters constant, in this particular equation we can write the relationship between diameter is inversely proportional to the RPM, and from this equation we can write that pitch is proportional to the diameter. As pitch is proportional to the diameter and diameter is inversely proportional to the RPM, one can write that pitch is inversely proportional to the RPM. So using this particular equation in our gear ratio equation, we can write that pitch of workpiece divided by the pitch of lead screw. So this gives the relationship between the RPM of the driver and driven, that means lead screw and the workpiece, and the relationship between pitch and RPM of different gears. So now suppose if we want to have certain amount of pitch on the lead screw, and we know the pitch of the lead screw, and we want to generate the pitch of the workpiece. So we have the amount of which we need to generate the thread on the workpiece. Now we need to adjust these two value by using the different gears. So by using all these equations, one can adjust the different gears available in the tumbler gear. So in tumbler gear mechanism, by adjusting the different gears available in it, one can obtain different thread cutting operation or the different pitch on the workpiece required. So this is the basic equation with which anyone can generate any number of pitch on the workpiece by setting the gears in tumbler gear mechanism. So I hope you got the clarity how this thread cutting mechanism is working and how the threads can be adjusted or can be cut by maintaining the different gears. Now with this thread cutting operation, one will come across the another important word, that is the thread chasing. So thread chasing is nothing but the repetition of the path of the tool during each and every time when the cut is repeated, because as we know directly the final cut cannot be generated on the workpiece as the large amount of material needs to be reduced. So the final cut is obtained by maintaining a different steps of cut one by one, and during each and every cut the tool needs to follow the same proper path. So the following the same path each and every time during the thread cutting operation, so that particular following of that particular path is called as the thread chasing operation. Means these threads are, or the cutting tool is chasing the already existing threads during cutting operation. That's why that is called as the thread chasing operation.